OABC is a parallelogram. We're told that the vector O to A is vector A, that's marked on for us. We're told that O to C is vector C, that's not marked on for us, so let's mark that on. Now, because this is a parallelogram, I also know that C to B is also going to be vector A. And I also know that A to B is also going to be vector C. We are told that P is the point on AB such that AP, this is 1/4 of AB. So this here would be 1 part for 1/4, and this would be 3 parts for the 4 parts in total. We're told that Q is the point on OC such that OQ is 2/3 of OC, which means this will be 2 parts and this will be 1 part if OQ is 2/3 of OC. Right, we need to find, in terms of A and C, the vector P to Q. So, P to Q. Well, what I'm going to do for this is I'm going to go from P to A. Then I'm going to go from A to O. And then I'm going to go from O to Q. So for the P to A bit, I can see that this is 1/4 of the vector C, but in the opposite direction. So minus 1/4 C. Next, the vector A to O. I can see that's going to be equal to the vector A, but in the opposite direction, so minus A. And then the vector O to Q, that is 2/3 of the vector C, and in the same direction. So a positive 2/3 C. So that is my vector P to Q. I just need to simplify this now. The minus A, there's nothing I can do about that. That's a term all by itself, so we'll just copy that down. But I can simplify the C terms. I've got 2/3 C minus 1/4 C. Let's just do a bit of rough working out to work that out. 2/3 C minus 1/4 C. I need a common denominator, so I'm going to write the 2/3 as 8/12. And I'm going to rewrite the 1/4 as 3/12. And I can see now that taking those away will give me 5/12 of C. And this is my vector P to Q in its simplest form.